Last time I took a detour and talked about JavaScript developer tools on the web, but now I would like to return to JavaScript and talk more about it, and more specifically, today's video is going to be all about functions. Well, first of all, functions are reusable chunks of code that can be called or invoked from different places around the application. They're essentially what amounts to basic building blocks for all applications, well, at least on the front end web. The code that can be inside of functions is either in one line or spread across multiple lines, and by invoking them we can basically call that exact same code wherever we want in our application. So a function consists of three components, and this is how to make it. First we type a function keyword, then we follow it up by a name, and let's just say I'll call this function say hi. Then we follow it by the parameter list, which is basically open and closed parentheses. This is where the parameters would go if we had any. Afterwards we simply open curly braces and break to a new line, and this is where we type our function code. I'll just log hi to the console. Save this file and I'll run it in Node. As we can see, nothing happens, and that's because we've just created a function and have not invoked it. To invoke the function we simply need to write its name, followed by the parameter list. Since in this case our parameter list is empty, we simply put the parentheses without anything inside. And now, after saving and rerunning the file, I get the result hi back. Sticking with the topic of these parentheses a little bit, I'll now make a function that requires arguments. This one will be the function, let's just say, multiply, and it'll take two parameters, a and b. And now, of course, since we're taking parameters, most likely we would want a value returned from this function, and the way to do that is simply to type the return keyword and then what we want here. The return keyword basically means that the function will result to the value on this line here after the return. And it simply tells us that after invoking this function with parameters, it's gonna give us the product of a and b. So let's test that. I'll actually create a constant variable. Let's just say product, and set it to multiply, and the parameters I'll pass are 4 and 5. And then I'll console.log the product variable, as well as the type of product variable at the end of the file. Save and rerun, and we get the number 20 here as the product of a and b. Of course, these were all perfect examples with the perfect data given, but sometimes in the real world we probably won't deal with perfect data. And just to show that, let's just say in this product variable and the multiply invocation, let's just change the first character to hello, the string. Now if we save and rerun, we get the, of course, hi from the say hi function, but the value of NaN, or not a number. Now this value is notorious for absolutely destroying application logic, so let's protect from that and say that first let's assign this to a variable and return that variable instead, and put a conditional statement here. Say if type of A is not a number, or type of B is not a number, return. And for the sake of simplicity, I'll just return the number 0, but we would probably handle this with some error checking. Now if I save and rerun the file, I get the number 0 here, and we're basically a step closer towards normalizing the behavior of this function, even with imperfect data. Now, so far we've only seen functions that require a name, but that doesn't always have to be the case, and I'll show it on this example. Let's just say we have an array of numbers here, some random one that I copy and pasted, and we'd like to get all elements that are greater than 15. So for example 50, 70, 18, 42, and that's it. So there's a nifty little method on arrays, or a higher order function called the filter. So let's just say array over 15 is this array dot filter, and the filter method basically requires a function as an argument, and that function takes the element here, one of these, and checks the condition we provide for each element, and simply gives us back the list of all those that pass it. So in this case we could create a function called is over 15, and it takes the element, and we say if element is greater than 15, return true, else return false. Of course, let's remember the type checking we did here and say if type of element is not a number, also return false. Now we can provide this function here and log the array, and it'll work. However, this is a very cumbersome way of writing a function, using the function keyword, giving it a name, where all we can do is actually create an inline function here that is also kind of different in a way that it uses modern syntax. So for this element we can simply use the equal sign and the greater than sign, which creates an arrow in a sense, and I'm using font ligatures, so if I zoom my font in, it basically does create the arrow. Let me unzoom a little bit. Now we can open the curly braces here and simply remove this function and paste everything in here. Saving and rerunning gives us the exact same result. Now those were or are called anonymous functions because they don't have a name and are simply just a function parameter followed by a body. We can also reuse them actually by assigning them to variables. like is over 15 can also be all of this here. Let me just cut it and copy it here. Of course, arrow functions are different than regular functions in that they don't need the curly braces. If anything, everything can be resolved in a single line, and we might not even need the return keyword. So we'll have to use a ternary operator for that, and I'll write it down here. But it's the shorter way of working with things. So if type of element is a number and element is greater than 15, we can now do this. Saving and refreshing. I mean, again, this function here in the filter requires the return of true or false, but if we return just the condition here, it'll reevaluate on runtime and give us the value of true or false. Saving and running gives us the exact same result. There's one more way that a function can be used that I forgot, and it's to immediately invoke some chunk of code. So I'll come to the beginning and right here. When we look at the say hi and the multiply functions, the line starts with the function keyword and then the function name, and then everything else regarding that function. This would be a function declaration, which basically means that the function was created and nothing else will be done. That's why the first time when I ran the command for running the file, nothing happened. Of course, we can also create function expressions, which can be immediately invoked by simply wrapping them in parentheses. Just writing function here. I'll just say for example, and let's not forget the parentheses here. Save, and when I run the code, that's the first thing that gets printed, because as an expression everything has changed and we don't even need a name here. We can omit it because it's immediately invoked here. That basically sums up everything I wanted to talk about today, so thank you for watching, I guess.